Hi, this is lesson 5.4. This is part 2, and we've been working on long division. Now I want to teach you a strategy called synthetic division. And the first thing we're actually going to do with synthetic division is use it for something else besides division. We're going to use it for substitution because it works for that too. And it's just a really neat little strategy, and I think it's a lot of fun to do. Now, first of all, direct substitution. You've been doing this for a long time. So if you have f of x is equal to this whole thing right here, we want to know what it's equal to when x is a negative 2. So we're going to plug in a negative 2. So you've been doing this forever, okay? So we have negative 2 raised to the 4th power plus 2 times a negative 2 raised to the 3rd plus 3 times negative 2 squared minus 7. Now, simplify. Remember your PEMDAs. Negative 2, that quantity to the 4th power is a positive 16. And then again, remember, use PEMDAs. We're only going to cube the negative 2. So we have the 2 outside, and that would be a negative 8. And then we have negative 2 quantity squared is 4. Okay, so now we'll simplify further. And then 16 minus 16 is 0, and then 12 minus 7 is 5. So that's your answer. So that wasn't too bad to do. I didn't need a calculator. I'm guessing you wouldn't need a calculator. When we have small numbers, when we're working with 2's and cubing them and raising them to different powers, squaring them, taking them to the 4th, not bad. But if that would have been like a negative 8 or something that we're substituting in, we maybe would have needed to get our calculator out, right? So there's this other method called synthetic substitution, and it uses what's called the remainder theorem. And to do it, first of all, we're going to make an upside down division box, and we're going to take the number that we're substituting in and put it right out front. So the next thing we do is we look at what we're plugging into, and we look at the coefficients. So we have a 1, 2, 3, and a negative 7. However, the one thing you have to remember that with this, you have to have the x's arranged in descending order. So we have x to the 4th, x to the 3rd, x squared. There isn't a plain x here, so whenever that happens, when you're missing one of the numbers in descending order, you put in a 0x. Okay, so now we're going to list the numbers. So we have 1, 2, 3, 0, and negative 7. So we list them right here. 1, 2, 3, 0, and negative 7. Now, we have an algorithm, which means those are the steps that you use for synthetic. And the first step is B for bring down. And then the next step is M for multiply. And then it is A for add. And that's it. This is a nice short one. And then you go back and you repeat the multiply add cycle until you're done. So step 1, bring down. You bring down the first number, and then you multiply it right there with the negative 2. And you write the answer here. So negative 2 times 1 is a negative 2. And then you're going to add. 2 minus 2 is 0. So multiply, add. Now we go back to the step right here, multiply. So we're going to take negative 2 times 0, and that gives us a 0. And then you add. Now we're going to go back and multiply, so you have a negative 6, and add. And then we're going to multiply, so you get a positive 12, and add. And take a look what the last number is. Same as what you got when you did direct substitution. So this is synthetic substitution. Now you might have thought, oh, that was kind of confusing, but boy, after you do that a few times, it is super fast. All right, let's do another one. So we have given that p of x is equal to all of this. What is p of 3? So in other words, we need to substitute in a 3 for x. So we're going to put a 3 is what we're substituting in on the outside. And the numbers, the coefficients are 1. Let's see. We have x to the 5th, x to the 3rd. Oh, we're missing the x to the 4th. So we're going to write 0x to the 4th. 3, 2. Oh, we don't have an x, so we're going to do 0x, okay? So we have a 1, a 0, a negative 2, a negative 1, a 0, and a 2. All right, here we go. And again, it's bring down, multiply, add, and then go back and forth. All right, so bring down the 1. Now we're going to multiply, we get 3, and add. Multiply, we get 9, and add. Multiply, we get 21, and add. Multiply, 3 times 20 is 60, and add. Multiply, 3 times 60 is 180, and add. And that is your answer. So if you did 3 to the 5th in your calculator minus 2 times 3 to the 3rd minus 3 squared plus 2, trust me, you would get 182. Okay, you can check it out yourself too. All right, let's do another one. So we're going to find out what p of negative 4 is. We have the x's, 5, 4, 3. Oh, we don't have an x squared. So 0x squared. All right, so let's set that up. And I'm going to give you a minute. 1, negative 3, negative 28, 0, 5, and 20. I'm going to give you a minute. I want you to try to do the process. Okay, bring down, multiply, add, multiply, add. Okay, you can pause it if you're not quite done yet, but first of all, we bring down the 1, and now we multiply, so you get negative 4. And then you add, which is a negative 7. Now again, we multiply, we get a positive 28. Add, you get a 0. Multiply, you get a 0. Add, you get a 0. Multiply, we get a 0 again. 0 times negative 4 is 0. And add, you get a 5. Multiply, you end up with a negative 20. Bring down, or excuse me, add, you get a 0. Your answer should be 0. So take a look at that. If you went wrong somewhere, go back and figure that out. Okay, so you're going to now do another little part of this assignment. I want you to do 32 through 39. The answers are here. The way to learn this is just by practicing and make sure you're getting the right answer. I will go ahead and do one problem here for you. This is number 32. You have to try plug in a negative 2 right here. And we're going to use synthetic, it's called synthetic division and the remainder theorem. And what that is what I called synthetic substitution. So we have a 1, a 4, say 3, 2, 1, a negative 8, and a negative 6. Go ahead and pause this if you want to try it yourself, which you should do that. All right, so we bring down a 1 and we multiply. Then we have a negative 4, and then we have a negative 12, and then we have a positive 24, and then we end up with 18 for our answer. All right, and then just a hint before I let you go here, on 33 we have x to the 3rd x squared x, but there's not a constant, so we would put a 0 there for the constant, okay? So you want to add a 0 when you do that. All right, go ahead and do these and come back in a little bit to watch part 3. Thanks for watching.